Hello, my name is Charles Fan. I'm co-founder and CEO of MemVerge. It is my pleasure to be here to share about AI memory and how do we privatize AI memory so that we can guarantee the security and privacy of the memory data that enterprise has. So first, let's look at how AI workflow works. Um, over the last 2 to 3 years, the large language model really revolutionized the AI industry. These pre-trained large models were trained using the data from the whole internet. And based on transformer models, these models were able to internalize the universal knowledge that's captured by the internet and are able to understand and generate language and other information forms based on any queries users have, whether it's from the users directly or from the AI agents that represent the users. And the training process happens and the inference process happens. Now, there are data that are not public and that is not in the whole internet, and those data are not captured by those foundational models. And these are proprietary data, whether it's personal data or whether it's institutional data that belong to enterprises or other organizations. And these data will need to be incorporated somehow uh, into the query so that the response can incorporate these data when the inference is happening. And there are popular processes such as RAG, Retrieval Augmented Generation, and MCP, the Model Context Protocol that can be called by the models. So these mechanisms are available to incorporate these private data into the inference process. So what is AI memory? AI memory is actually critical. If these AI models are perceived to be the supercomputer uh, and sort of the new processing power that can process information, the AI memory is the memory and storage systems where all the state of this AI supercomputer is captured. So there are at least three layers of AI memory if we take a memory-centric point of view into the AI system. The very first layer of AI memory are the model weights themselves. And these are the hundreds of billions or even trillions of parameters that are associated with these neural networks. And through the training process, these parameters were tuned so that to capture the knowledge and underlying logic between all of the public knowledge. And therefore, this is the first layer of memory that remembers the universal public knowledge. And really the amazing power of the large language model are reflected in the actual parameters, these many, many billions of parameters that are part of this neural network. Um, Also within the model, there is another layer of memory besides the model weights, and that's KV cache. So what is KV cache? It is the intermediate results, from all these matrix multiplications that were generated during the AI inferencing process. These are generated both during the prefill stage as well as the decode stage, and the size of this KV cache grows as the number of input tokens increases. Um, and this is necessary because without it, if you every time recalculate all these intermediate results, it's going to become impractical in terms of how much compute resources is needed to perform inference tasks. By remembering and keeping these in a short-term memory or cache, you are able to make the whole inference process much more efficient so that it's even practical to perform the inference task. And as the input context window grows with each new versions or new generation of large language models, the amount of KV cache also grows. That's quadratically to the speed that the input token grows. So the amount of data that need to be kept at the KV cache grows very fast. Therefore, classically, both model weights and KV cache are being kept in the GPU memory. Nowadays, there is emerges necessity for KV cache stores that's outside of GPU memory, either in the host memory systems or other memory-based systems or other storage systems. But both model weights and KV cache are part of the large language model as it performs the inference tasks. This third layer of memory is a little different. This is commonly referred to as context. This is a data that's not necessarily captured by the model itself, and this is often the private data that institutions have. But these data are necessary to provide the relevant background information, sort of what it remembers from the past interactions or relevant private data that's needed for the AI models to generate the response appropriately. These data are private, and sometimes even if model have it, by included in the context, it can emphasize the relevance of this data so that the model put more weight onto this. The typical data that's part of context could include what we talked about, the RAG, that is a vectorized form of the enterprise data, as well as long-term memory. This is what we can remember from the past human-machine interactions so that the profile of the user, the past episodes, what the user performed, can come in handy to include it in the context in order for model to give the appropriate answers. So this layer of memory is outside the model, and there needs to be a separate system to keep it. And the privacy of this type of memory becomes very important, but because it's often related to very personal informations or institutional informations that cannot and should not be mixed with each other. Like my memory should not be mixed with your memory, and I don't want other people to peek into my memory, and I'm not interested to look into the memory of the others. So how do you keep the privacy and the separation between these context memory becomes paramount. And now the industry have noticed the necessity of this long-term memory system. For example, OpenAI have started developing their long-term memory system over the last couple of years. And this is a social media picture I got from a high school friend. And he discovered that OpenAI actually has been remembering their past conversations. So this is kind of amazing on one side and kind of scary on the other. On the amazing side, by remembering that my friend that really works with semiconductors, investing stocks, and has certain approach to his investments, and really loves his dog. A really useful context information for certain queries he might ask OpenAI in the future, and allows OpenAI to give more relevant and higher quality answers. Now, on the scary side, these are very private information, and you are not sure whether you want OpenAI to know about it, remember it, and do whatever they want with it. So on one hand, it is critical to have a long-term memory system that can aid to generate the large language model to generate the best answers. On the other hand, you want this memory system to be private, to be secure, to be under your control, and that can also work with the data you already have, and that can work across multiple models you might want to work with. And this is both for consumers as well as for the enterprises. And so what MemVerge, what we've been working on over the last year is to create a private version of this long-term memory. We call it intelligent memory that can work for the enterprises, where enterprise can deploy in their own environment and integrate it with their own AI workflow, and it can work with foundational models deployed both inside of the enterprises as well as outside the enterprises in the API services. But the memory itself is private and secure and under full control by the enterprises. So this is kind of what's under the cover of this intelligent memory system. It is integrated with the AI flow in three ways. It has an MCP server that can be called by the model themselves through the two calling mechanism. It can be integrated with the gateway systems and intercepting the conversations between the models and agents and users. It can also integrate it to the front end, to the chat uh, API, so that they can directly interacting with the users as well. And the enterprises can decide how they want to deploy the system with one or more than one of these methodologies. Within this intelligent memory, if you look at the top left hand, it's the core memory. So when you want to remember these past interactions, there are actually different layers of memory. There's episodic memory that remembers all the events that has happened in the past. And this is typically obtained by the session log from all these past conversations and stored and organized in a certain way that's easier for retrieval. And then there are semantic memories that are really summaries of these episodes so that it can be more easily remembered and takes less spaces and also easier to look up as well. What can also be extracted from these episodic memory and semantic memory are the personal profiles. For each of the user ID, each of the group ID, you can have certain characteristics, certain properties that's associated with them, and that will be helpful in future queries from those users or from those groups. And then last but not least, there are the procedural memories. That's really the muscle memories that remembers the procedures or the workflows, how certain person or certain group approach certain things, the steps it takes to do things, and this will be important for agents to perform certain tasks in the future. There are memory models. These could be either private models or public models that can be incorporated to help generating these memory items, and there are algorithms built in to generate these memory stores as well. And the data were obtained through the MCP server, through a data ingestion agent to be stored and indexed for retrieval as part of this memory. And then another critical component is this context retrieval agent. This context retrieval agent is connected into these various memory systems. And when it receives a new query, it uses an internal specialized retrieval model to retrieve the most relevant memory items, as well as a potential connection to the other private data sources to get the most relevant context to generate the new query, including this new context information to be passed to the model. So that model has all the most relevant information in order to generate the best answers to the agent. And this is a system that's evolving in the real time. So the more you use it, the more sophisticated your context retrieval agent becomes, and the more complete or the more extensive your memory becomes. And so that the answers from the models can become better and better as it get to become more and more familiar with each of the users and each of the agents and each of the groups. Now, at the same time, these data store are completely within the power of the enterprises and its users, and it has a memory API that can allow users to modify the memories, adding items, editing items, or removing items, deleting memories to ensure um, the privacy and control that users have over this memory system. So now here are just some examples how this memory system can be very useful. You could have, two financial analysts in this case, Ravi and Sophie, and they've been working with the LLMs on their financial analysis projects, where Ravi is going through a DCF calculation on a particular company's Q1 financials. This is a discounted cash flow analysis. It's kind of a technical analysis, and LLM is giving Ravi pretty good assistance in doing that. And this is being captured in the background by the memory system. At the same time, Sophie, the other analysts, are doing some other research for a particular retailer, and this is to analyzing the foot traffic trends across the top shopping malls. And it's LLMs is able to providing good answers to help Sophie performing these research. And so while these research and analysis is happening, the model is answering their questions. The memory system is remembering it. So as in the background, the memory system can remember certain uh, uh, pers personal traits for Ravi and for Sophie, where Ravi is more into quantitative analytics, or liking these tables and charts, and it's quite technical and results oriented and analytical. Where Sophie is strategic and more into kind of insightful narratives and likes more visual, engaging charts, and so on and so forth. So just like every one of us, any one of us, each user have their own ways of approaching things and particular angle and particular aspect of the project that they are paying more attention to. So with this happening in the background, as memory is being incorporated into the system, you'll see that with another question that both of Sophie and Ravi asked the models to get insights from Wingstop's Q2 2024 results, the model actually incorporated these memory and give sort of different type of summaries to Ravi and Sophie based on the personal preference of those of both of them. And this happened passively in the background without Ravi and Sophie actively asking model to do certain things for them. So this is a kind of a passive automatic inclusion of the memory into these inferences. And this is kind of to the more extreme case when Ravi and Sophie asking LLM to help draft a recommendation whether to buy or not to buy Wingstop stock based on their personal angle, where they pay more attention to. That LLM have different recommendations: neutral for Ravi and moderate buy for Sophie, even though it's based on the same data and same queries, just because it's coming from two different people and because of the different memories they have, the model could drive towards the different answers here. This on one hand could be surprising, on the other hand, is not, because every knowledge worker is different, and in some ways, the model is not to replace every knowledge worker, but it is to enhance and magnify or amplify each of us. And it's for many of the tasks, uniformity may not be the most desired outcome, but rather still maintain the diversity of personal approaches with the help from LLM that enhances and augment the approach of each individual for certain tasks is the desired outcome. So we believe intelligent memory is essential for this kind of human-centered enterprise AI systems, where it stores and recalls the relevant memory from the past and set up tech context for each new session, each new agent, and this can work across all the models. And this really help really multiply and amplify each humans, really having AI to be the best productivity enhancer that person could have. Now, at the same time, because of the sensitivity, how intimate this memory system can get in with each of the persons. Data privacy is critical for AI memory. Therefore, it is our belief for many of the enterprises as well as consumers, the operator of these large models might not be the best place where these memory would sit. That you would like this memory to be sit close to you and for the enterprises to be deployed within your own private network, either within your virtual private cloud or on-prem. And for individuals, you want this to be something that you have full control over, that no one else can access your memory except your own. So that is how do you create AI memory and make it your own AI memory. Just to introduce MemVerge as a company, we have been around for almost 8 years now, and from the beginning that we are working on big memory. And over the last couple of years, we are more focusing on big memory for AI, both the intelligent memory that we introduced as well as the underlying infrastructure that enables it. We have got about 100 million investment from financial VCs as well as with industry leaders and with our customers in financial services, in high performance computing, as well as in cloud service providing business. It's a pleasure for me to share what we do with you, and thank you very much.